Okay, so this is the last video from chapter 1, so hopefully you're studying, and this is the last one. This last video is on the difference quotient, which the difference quotient is just a special way to represent average rate of change. So we talked about average rate of change in the last time, which is a special slope of the secant line through a curve, slope of the line through 2 points on my curve, and it gives me the average growth, the average rate of change, average increase, or the average decrease, of a function that's nonlinear. Although you can do it for linear functions, it's just always going to come out slow. And so what the difference quotient is, it just allows us to manipulate this, alright? And that's what the hard part about it is, the manipulation. And the reason why, there is a reason why we do the difference quotient. And it has to do with what eventually, if you guys go on to calculus, the difference quotient plays a very vital role in the concepts of slopes when you get to calculus, and you'll use it over and over and over again. So we introduce it here in algebra, in case you are going on to calculus. And it's good practice following order of operations and simplifying expressions anyway. And that's really what the biggest thing is here in college algebra, is just setting it up and practicing order of operations and simplifying expressions algebraically. Alright, so just like I said, it is, and this is sort of the diagram that they give you in the book, and it's a pretty good diagram. And so there is my average rate of change line. So what we do with the difference quotient is we take the average rate of change of a function and we do it generically without actually plugging in numbers. So instead of saying from 2 to 10, I'm saying, well, so from any x value to any different x value in my function. And we differentiate what the difference between my x value is using h. And again, there's a reason why we do that, but it requires calculus to really talk about it. What h represents, it represents the different x value, right? If x was 2, x plus h would be 2 plus h, so h would put me someplace else. It would put me at, like, if h was 2, it would put me at 4, right? I'd start at 2, and then I'd go 2 plus 2, which would put me at 4. Right? So it allows me to look at any 2 points on my function. That's what it allows me to do. So x represents where I'm starting. The plus h means I've moved to a second point. Right? I moved over to a second point. Alright, so this would be point 2. So what this would have been is this would have been x2, y2. This would have been x1, y1 in my previous definition. But instead of using those, we're going to say any x and any x2. We're going to represent x2 by x plus h. It still represents an average rate of change. Right, that's what that red line is. It's the line where I find the slope. Slope is the average rate of change. Right? So it's still finding a slope of a line through 2 points on a curve. It's just generic points this time. Right, so the difference quotient is f of x plus h minus f of x all over h. Again, f of x plus h is the hard part, minus f of x. That's the same as f of x2 minus f of x1. In our previous rule, and then over h, well, that h would have been the x2 minus the x1. That's the change in x. That's what that represents. This is the change in x. And so it does find my average rate of change. Right? So this is what we solve. And the hard part is solving this. Right? And h can't be 0, meaning there has to be some type of change, so I don't get division by 0. So it can't be a horizontal line. The hard part about this is simplifying, and really this is the hard part here, and that's what we're going to practice. And when it's all said and done, it should always simplify to where I can get rid of the divide by h. That's sort of the goal. As soon as you get rid of the divide by h, I can cancel it out, then you're completely simplified. And we'll do a few examples. And so basically there are 3 types that I can ask you. I'm going to ask you either a simple linear case, where I want you to show the difference quotient, a simple a quadratic case, can't spit it out, or simple rational, where I've got a simple fraction. I'm going to do one of each of those. Alright, so the first example. Alright, so they sort of break it down because, again, the hard part is that x plus h. Right? That is the hard part. Right? So we do that first. So part A is asking you to just do this first part. Right? Then we'll do the rest of the difference quotient once we set up that. Alright, so A is just asking you to find x plus h. And so I'm replacing x with x plus h. So if you think about it, it'd be 3, there's this x value I plug in, that's my input, minus 2. Well, I'm replacing the input with x plus h. And so I'm going to get 3 times x plus h minus 2. I'm taking my input, multiplying by 3 and subtracting by 2. And then simplify that. So distribute your 3, so 3x plus 3h minus 2, and there's f of x plus h. And that's it. Doesn't simplify any further than that. There's the answer to A. Alright, then B, the difference quotient. I have f of x plus h minus f of x all over h. And so now it's just filling in. And so the first part is what I found here. Alright, so what goes in here is the 3x plus 3h minus 2. And then I subtract, and make sure you put parentheses, because I'm subtracting the entire function. And so f of x represents the entire original function. So I go back up here. F of x was 3x minus 2. That's what goes in here, is what I'm subtracting. 3x minus 2, and I need parentheses because it's minus the entire expression. So I have to remember to distribute that, and that's an easy mistake to forget. And then it's all over h. Alright, and then that's step 1, getting it plugged in correctly. Parentheses, parentheses, parentheses. Alright, then step 2 is simplify. Well, the first set of parentheses just drop because there's nothing out front to multiply. The second set, though, I have to distribute that negative. That's why they're very important that you don't forget those. So I have 3x plus 3h minus 2, and then distribute your negative. So I'm going to get a negative 3x. Negative times the negative 2 will give me a positive 2 all over h. At this next step, everything up top that doesn't have an h in it should cancel out, and it does. This 3x cancels with this negative 3x. This negative 2 cancels with that positive 2. And so all I'm left with up top is a 3h. And in the bottom I still have the h. And then this is where it reduces, right? H divided by h is 1. And so the answer is 3. And it should make sense. It's a line, right? Slope was 3. You go back and look at it. And remember, difference quotient represents average rate of change. Since it's a line, all rates of change are equal to the slope. All rates of change are 3. So the average rate of change is 3, and that will always happen with lines. Now you need to show the work, if it's a show your work problem, but that will always happen. It will always simplify to a single number. Alright, so the next example, which I'm going to give myself more room than I gave myself here, I'm going to do a quadratic example, which is going to require me to do a little more work. Alright, so again, same question. So f of x and the difference quotient. Alright, make sure I ask the question. So given f of x is equal to 2x squared plus 5x minus 3, A, find f of x plus h, B, find the difference quotient, for f of x. Alright, so just like the last problem. Alright, so A first. Alright, so again, everywhere there was an x, we're going to replace that with x plus h. And when I do it, I need to put parentheses around it. So when I'm doing f of x plus h, it's going to be 2 times parentheses, x plus h, end parentheses, and then square, plus 5 times parentheses, x plus h, and then don't forget the minus 3. If I were going to forget something, the minus 3 is what I would forget, so make sure you're careful. Alright, now order of operations and simplifying this, which is the hard part of simplifying. The 2 stays. Remember what this is, and I'm going to write it out. X plus h squared really means x plus h times x plus h, right? That's what squares mean. It means I'm multiplying by the same number twice. Alright, which means I have to multiply this out. Alright, so again, I'm going to use FOIL. You can use whatever method you use to multiply 2 binomials. So first would be x times x, which is x squared. Then I get an x times h, and another x times h, so there are 2 xh's. And then last, there's an h times h, which is an h squared. Alright, so that's what it multiplies out to be. X plus h times x plus h multiplies out to be x squared plus 2xh. Alright, then here I'm going to multiply through by my 5. So I get 5x plus 5h. Still have the minus 3, don't lose it. Alright, next step, distribute your 2. And so we get 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 3. And there's f of x plus h. And there's nothing in there that's a like term. You cannot simplify that, so don't try. You can't. You can't simplify it. Alright, so there it is. There's the ugly, messy expression. 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 3. Alright, so part B, the difference quotient. F of x plus h, which I have above, minus f of x, all divide by h. Alright, so the first thing is just plug that expression in. Again, my rule of thumb is always put parentheses so that I don't make any silly errors. And then the second thing is to double check to make sure I'm copying it down right. I tend to have issues with copying things from one thing to the next. Alright, so I double check myself. 2x squared, 4xh, 2h squared, 5x plus 5h. 3. Alright, then it's minus the original function. So I gotta go back up and remember what the original function was. So this was the original function, so that's what I have to subtract. 2x squared plus 5x minus 3. So 2x squared minus 5x plus 3 all over h. And now it just comes down to being very, very careful that I don't accidentally miss anything. That's my biggest thing here. Alright, so first of all, don't forget you have to distribute that negative. That's why I had to have this set of parentheses to remind me to distribute that negative. This one I can drop my set of parentheses. So I just rewrite it for the third time, making sure I'm very careful. The hardest part here is accidentally missing one of my expressions. And then now distribute that subtraction. So I get negative 2x squared plus 5x. Was a positive 3. That should have been a negative 3. Sorry about that. Now it's a positive 3 when I multiply positive 3. Still all over h. I'm going to double check myself. Negative 2x plus 5 plus 3. Okay. At this point, once I've multiplied and distributed my subtraction, everything that doesn't have an h in it should cancel. If it doesn't, you've missed a number somewhere. This 2x squared cancel with that negative 2x squared. This 5x cancels with that 5x. This 3 cancels with that 3. And if you look, everything that's left over has an h in it. Right? I have a 4xh plus a 2h squared plus a 5h all over h. And so what I can do then here is I can reduce this. There's two ways. You can factor out the h, or I actually think for students the easiest way is to split the fraction into the big fraction into 3 little ones. 4xh divided by h, 2h squared divided by h, and 5h divided by h. And then reduce, right? Those two h's reduce to 1. I can reduce one of those h's with one of those, so I still have one left over, and that h reduces with that one, and so the difference quotient simplifies to 4x plus 2h plus 5, and then you're done. And again, typically with quadratics, that's what happens. You get left with an x term, an h term, and a constant term, or a lot of times. And so that's the difference quotient with a quadratic. Alright, so with a linear function or a quadratic, the last one we're going to look at is a division case. Right, if I have a simple division. So again, same thing. Given f of x is equal to 1 over 2x. Simple division. A, first thing find is x plus h, and then B, solve the the difference quotient. Difference quotient for f of x. Alright, a first. F of x plus h. Alright, so again, where there was an x value, I replace it with x plus h. So when I do that, I put it in parentheses. So I get 1 divide by, instead of 2 times x, 2 times parentheses x plus h. And then the only thing that simplifies, you could distribute the 2. So 1 over 2x plus 2h. Alright, so there's my x plus h. Now the difference quotient. F of x plus h minus f of x all over h. So the first thing is writing it out carefully. So f of x plus h was this expression, and again, put it in there as parentheses. So 1 over, parentheses, 1 over 2x plus 2h minus f of x. F of x was 1 over 2x. And then that whole thing, that's the top part of the fraction, still over h. And so this is a complex fraction. Well, how do I simplify a complex fraction? Well, what I do is I clear out the little fractions. I find the least common denominator, multiply the top of the fraction, the bottom fraction by it. And so there are two denominators. There's the 2x, right, this is a denominator, and then there's the 2x plus 2h, that's a denominator. And so whatever you do when you have this type of expression is I want to get rid of the little fractions. Well, I multiply by each of the little fractions denominators. So I'm going to multiply by 2x and 2x plus 2h. So I don't change anything. Remember, in order to not change anything, I have to multiply by the same thing up top that I do on the bottom. And so the same thing in the bottom of the fraction. Right, so 2x plus 2h, 2x multiplied by up top, and the same thing in the bottom. And so what we're doing is we're multiplying. And so I'm going to write it out. You might be able to cancel in your head, and if you can cancel in your head, that's fine. I'm going to show you what it is, so I'm going to write it out. So everything gets multiplied by the 2x times the 2x plus h. So that's the up top part. And then still on the bottom, I get h times that expression. Keep wanting to forget my 2 in front of the h. Alright, so the bottom just stays the bottom. What happens is we did, the whole reason we did that is so that this fraction gets gone. Right? That will cancel with that, or reduce. The 2x will reduce with that 2x. Now I'm still left with something. In this expression, I'm still left with the 2x, and in this expression, I'm still left with the 2x minus h, and don't forget there's still a minus here that separates them. Alright, so in my next step, I'm going to write down what I'm left with. Alright, so I'm left with 2x in the first term, minus, leave the parentheses, they're important. Most students forget those parentheses, so they forget to distribute the negative. Don't. And then it's still all over that ugly thing. Alright, can't take care of anything in there. Nothing reduces yet. Don't cancel anything out. Nothing cancels because of the minus sign. So don't. There's a lot of 2's and x's and h's going on here. Nothing reduces at this point. Alright. My next step is to distribute that negative. When I distribute that negative, I get a 2x minus a 2x minus a 2h. Still all over that ugly bottom number. Now, that 2x cancels with that 2x. Up top, I'm left with a negative 2h up top. I still have an h times a 2x times a 2x plus 2h. Right, this h will reduce, so they're gone. And so all I'm left with, and it's up to you, there's a 2 that's floating around. You could also reduce the 2 if you want to. So again, there's one more step. You could cancel this 2 with that 2. And so the final, most simplified answer would be left with a negative 1 up top. I'm left with an x times the 2x plus 2h. Right, and there is my final answer. Right, so make sure that you look over these. I posted videos from the 4.4. Again, if you want to look at those, you can. They've got some more quotient rule examples, so again, it's optional. You don't have to. The book just has some. They have some nice videos that they've already pre-done. With additional problems, you can look at some average rate of change and some more on the difference quotient. It's just an additional resource that's free to you as part of the purchasing the book. So again, if you want to look at those videos, I've posted them in the webassign under homework because it's the only way I could post them. But it's not due for points or anything, even though it says it is. It's not. There's no points going to go in the gradebook for it. But it's there for you as an additional resource to help you practice and get ready for this first test. So hopefully you're looking over all of the material, getting ready for exam 1. The biggest thing is just have all your notes and things ready to go when you take the exam. The exam is timed, so you don't have a lot of time to go searching for things. You need to make sure you've got your pen, paper, pencil all ready to go. So you're ready to take the test. You're not hunting anything down because you don't have the time to do that. All right, so make sure you have your notes with you, your pencil, your paper, and you're ready to go.